insert and open up the surface extractor module. And again, we'll go to File, Load Object Map, and we'll load the object map that we just created. We'll go to Generate, Extraction, and we'll click on Objects. Now, I'm only interested in the femur, so I'm going to switch off the tibia object. And I'm going to extract the initial surface with the default parameters. So we'll go ahead and hit Extract. And again, we'll just wait for the extraction process to run. Note the number of polygons, just over 59,000. So we'll hit Done, and we'll save this out to our surface file location, and we'll call this femur. And we'll say GEDC9513. We'll set the format to STL and then hit Save. Now we'll increase the keyboard size to 5 and then hit Extract. The extraction process will run. Again, we send the number of polygons. And again, we've decreased the number of polygons by over half, so we're just over 21,000 here. Let's click Done. And let's rename this and hit Save. Finally, we'll set the keyboard size to 7 and then hit Extract. The number of polygons will be returned again. And again, we're just over 10,000, or just under 11,000 polygons. We'll hit Done. And then we'll change the name and then hit Save. So now I'm going to go back to PowerView so we can take a look at these data sets. So with File, Open, and we'll select the keyboard size 3, first of all, and hit Open, and we'll hit Apply. Let's take this around for the front. So you can see it's pretty blocky. So let's go ahead and take a look at the next surface that we generated. So we'll go to Open, and we'll select the femur with the keyboard size of 5, and hit OK. Now, I'm going to hit Apply. It's going to display this over the initial data set, and as you can see, this data set's a lot smoother. So if I toggle off the display here, it may be a little difficult to see here, but you see that there's less details and more smooth. So let's take a look at the effect of the 7 keyboard size of 7. We'll hit OK, and we'll hit Apply. So again, it's even smoother than the keyboard of 5. So we toggle off, and maybe we'll toggle off between keyboard 7 and 3. And you see a big difference there. So you can play around with these parameters, play around with the advanced parameters, and see what effect they have on the surface and how they allow you to optimize your surface for use in your third-party software. So I'm going to call out PowerView here, and actually it may be a little difficult to see those differences. So I've actually got a slide just to run through those differences quickly. So you see that we have the 3 models of the femur side by side. The first is keyboard size 3, second has been extracted with keyboard size of 5, and the final one, keyboard size of 7. And as you increase keyboard size, you get a much smoother surface. So we went through CC segmentation and generation, surface generation. We also went through bone segmentation from MRI and surface generation. That really concludes the demonstration portion of the webinar today. So let me open it up for some questions from the user base. So please feel free to submit any questions that you may have about surface extraction, bone segmentation, anything that we've discussed today, or anything that we've kind of mentioned but not really introduced. So I have a question here, and it is, what surface file formats do we support? Okay, well, I actually have a slide prepared for this very question, and so if we move over to that slide, here are the surface files formats that we support for polygonal surfaces. So as you see, the more common ones are in there, IGES, SCL, Inventor, Poly. And if we go forward from there, we'll see the contour surfaces. These are the formats that we support for the contour surfaces. Just refer to the formats supported by your CAD, your FEA, FEM software prior to saving out of Analyze. But as a rule of thumb, for polygonal surfaces, I'd suggest saving out in the .scl file format. It's widely supported, and it's supported by most third-party software. For contour, you probably want to stick with IGES